Welcome back, guys. Today we are going to be talking about graphing quadratic functions. So this is the next section in chapter 0. We are still just reviewing some concepts from Algebra 1 and 2, and one of those is graphing a quadratic function. First, we'll start out in graphing standard form, which, as a reminder, is f of x equals ax squared plus bx plus c. Ax squared is known as your quadratic term. Bx is your linear term, and c is your constant. And a, b, and c are all real numbers. And a cannot be equal to 0, otherwise it would not be a quadratic. If there was a 0x squared, that would mean that term would not be there and it would just be linear. So a cannot be 0, but then x squared and x are your variables. There's going to be numbers there for a, b, and c. Keep in mind also that f of x is the same thing as y. It's just saying the function in terms of x. In order to graph a function that looks like that, it's going to look like a parabola. That's the shape of a quadratic function. And the first step is to find the equation for the axis of symmetry. That's the line, the vertical line that cuts the parabola in half. You'll use the formula x equals negative b over 2a. So the b and the a are coming from the standard form equation. And the x equals is saying this is where the vertical line is. Remember, x equals a number is always the equation for a vertical line. So this will simplify to some number, and you'll have x equals whatever the number is. You'll draw that line on your graph, and then you'll find the coordinate of the vertex, step 2, by taking that number and plugging it back into the equation. Step 3 is to find some other points on the graph. Some options and helpful tips are that the c value is always going to be equal to the y-intercept, because when you plug in 0 for x, both of the first two terms with variables will cancel, and you'll end up with just c. So c is the y-intercept. The a value is kind of like the slope. I put that in quotes because it's not linear, so it doesn't have a constant slope. But you can kind of think of it as the slope to the first point away from the vertex. And then, other than that, you can always plug in any extra x values into the equation to find more coordinates. And keep in mind that since the parabola has an axis of symmetry, it's the same on both sides. So you can reflect any point that you find over the axis of symmetry to find another point on the other side of the axis of symmetry. Let's do an example together. It says graph f of x equals x squared plus 2x minus 3 using at least 5 coordinate points. First, identify your a, b, and c value. A is 1, since there's nothing in front of the x squared, we assume that it's a 1. B is 2, and c is negative 3. Step 1 is to find the axis of symmetry. I'm going to label these now. You don't have to label step 1 in the future, but it would be helpful for you to label axis of symmetry. Write your equation, x equals negative b over 2a. Fill in the value. The b value is 2. The a value is 1. Simplify that. Negative times 2 is going to be negative 2. 2 times 1 is going to be 2. And we know negative 2 over 2 reduces to negative 1. So our axis of symmetry is x equals negative 1. Next, step 2, you're going to find the vertex. In order to find the vertex, you're going to take the answer that you got from step 1 and plug it back into the function. So we're going to do f of negative 1. So in the equation that they gave you to graph, you're going to replace anywhere you see the x, the variable, with a negative 1. Simplify that with PEMDAS. Negative 1 squared means negative 1 times negative 1, that's positive 1. Then multiply 2 times negative 1 is negative 2. Then add and subtract 1 minus 2 is going to be negative 1, minus another negative 3 would be negative 4. So that's our y value, since that's f of negative 1, that's your y value. Putting that together with the x value, you get a vertex point negative 1 comma negative 4. The vertex should always be on the axis of symmetry because it has the same x value as the axis of symmetry. And the vertex should be in the middle of the parabola. In order to graph this, I'm going to make some graph paper on my background. Remember, you can do that on OneNote by clicking View and then changing your rule lines in the back. And I went ahead and drew a coordinate plane for us here. I'm going to highlight my axis of symmetry. It was x equals -1. So that's a vertical line with an x-intercept of -1. Keep in mind that's not actually part of the graph for the parabola. It's just kind of a guiding line for us. So I'm just going to draw it in a different color or in a dotted line to show it's not actually part of this answer, but it is helpful. So then I'll put my vertex on here at -1, -4. Notice it falls on the axis of symmetry. And next, I'm going to look at the c value, which was -3. And I know that means that my y-intercept is -3. Notice also that my a value was 1. So from the vertex, if I'm looking at a slope of 1, that would be up 1, right 1, which lands me at that same point where the y-intercept already is. I can reflect the y-intercept over to the other side of the axis of symmetry by noticing it's 1 unit away to the right. So I'm going to go 1 unit away to the left of the axis of symmetry. And I can't just keep doing a slope of 1 because if I did that, it would become a V shape. And that's not correct. I don't want it to be a V shape. That would be absolute value. I want this to be a U shape called a parabola. So I have already used my A value and my C value to find extra points. So therefore, I'm going to have to plug in some other values to find extra points. So I would always try to stick close to the points I already have. So notice I already have a point for the x value of 0, I already have a point for the x value -1, and I already have a point for the x value -2. I could either plug in, I would go probably one more away from that. So I could go to +1 or I could go to -3. They're going to be the same because they're equidistant from the axis of symmetry. So you just pick which one's easier. 1 is easier to plug in than -3. So I'm going to plug in my x value of 1 to the equation. So 1 squared plus 2 times 1 minus 3. Follow PEMDAS, that's going to be 1 plus 2 minus 3. So 3 minus 3, that's going to be equal to 0. So my coordinate is 1, 0. And I can reflect that over to the other side of the axis of symmetry. I know that another point is going to be -3, 0. And then I can go ahead and draw that smooth curve called the parabola. It should be a U shape. Okay, I'm going to give you another example. This one is an extra example. It's not from the book, but I wanted you to see this one because notice that it doesn't have a linear term. It just goes quadratic term 6x squared, constant term 4. So what are we going to do? Our a value is 6, our c value is 4, and our b value is 0 because there's not a linear term. So when we go to find our axis of symmetry, sometimes you'll see that abbreviated. It's going to be x equals -b, so -0 over 2 times a, so 2 times 6. 0 divided by anything will always give us 0. So our axis of symmetry is x equals 0 this time. Plugging that in for the vertex is going to give us y equals 6 times 0 squared plus 4. Again, 0 times anything is going to be 0. So that first term is going to cancel out and we'll be left with just 4. Meaning that our vertex is going to be the point 0, 4. Notice that's the same as our y-intercept. That is the y-intercept. So when we go to graph this, we can't use the y-intercept as another extra point because the y-intercept is the vertex. What you can do in this case is look at the a value, 6. Let's go draw a graph. If you want, you can go ahead and draw the axis of symmetry on here. It's x equals 0, so that's just the y-axis. You can place your vertex on 0, 4. And then since you have an a value of 6, it means that you can go up 6 and right 1 to get to the next point. So if we go up 6 and right 1, because 6 over 1 is the same as 6, that would place us at the point 1, 10. So we can also reflect that point to -1, 10. And then we have our parabola. If we needed any extra coordinates for this, we could go ahead and plug in a 2 for our x. It's going to be off this graph because I know 2 squared is 4. And then 4 times 6 is 24, plus 4 is going to be 28. So I could say that I also have points at 2, when x is 2, y is 28. And then I would also know that -2 would give me the same value, 28, because of the reflective property. And I could draw that if I wanted to, but I think you get the point. Okay, here's another practice problem where you're graphing a parabola and it's a quadratic function because it's x squared and it's in standard form ax squared plus bx plus c, and you're using 5 coordinate points. So you can pause it and try that one and then come back and see if you got that right. And I highlighted a table that had all 5 points that I used on it, so you can double check your points there and see if you had the same. Next, we're going to talk about the key concept of the maximum and minimums of a quadratic function. You might have already noticed this, but the vertex is always the bottom or the top, in other words, the maximum or minimum of the function, and the y-coordinate specifically is the max or min value of the function. So you also might have noticed, or you might remember, that if the a value is positive, the parabola opens up and it has a minimum. Whereas if the a value is negative, the parabola opens down and it has a maximum. We'll use that to answer questions about max and min. For example 3, it's asking us to consider this function. It's a quadratic function because it has x squared in it, and it's in standard form. And we want to determine if it has a maximum or minimum value, find the max or min, state the domain and range of the function. A little side note here, remember domain is always going to be all real numbers because you can plug anything you want into a quadratic function, so that's -infinity to +infinity. And the range is either going to be the min to infinity if it opens up, or it's going to be -infinity to the max if it opens downward. So you're going to pick one or the other. This one has an a value that's negative, so that tells me that it opens down. And I could always draw a little sketch if I wanted to. It's saying that it has a maximum. So this one has a maximum, and in order to find the maximum, I know that the y-coordinate of the vertex is the maximum. So I need to find the vertex. In order to find the vertex, I use the formula for axis of symmetry for the x value, -b over 2 times a, and I simplify that. So I get -12 over -6, which simplifies to 2. And I plug that back in to get my y value. I'm going to go ahead and use the calculator here just for the sake of time. And I got y equals 23. So putting that together, my x value is 2, my y value is 23. So my vertex is 2, 23. But for the max value, since it said find the max value, I'm only really looking at the y value. So I can say this function has a max value of 23. The maximum value is 23. No matter what, if it has a max, a min, whatever, your domain is always going to be all real numbers. So to represent that in an interval, you'll say -infinity to +infinity. And since it opens down, I know my range is going to start at negative infinity because it's going down forever. And the highest, the maximum value is 23, so it can only go up to 23. It can equal 23, as we saw when x equals 2, y equals 23. So that's why I use a bracket there to represent that the y value can equal 23. Remember, domain is x, range is y. So you can have anything for x, but you can only get numbers between negative infinity and 23 for y. So you're never going to plug in a value for x and get 24. You're never going to get 100, anything like that. You could get negative 24, you could get negative 100, you can get any negative number, but you can't go above 23. Go ahead and try the extra practice problem for this type of question. And then check and see if you get it right. You can pause the video if you want. And then we're going to do this extra example, graphing from vertex form. So you'll notice this one's not in standard form. This is vertex form. Let's go to this box real quick. Vertex form looks like this. F of x equals a times the quantity x minus h squared plus k. In this function, x is still the variable. A, h, and k will all have numbers. So a is still the same as standard form, but then h and k are a little different. H and k help you find the vertex. H comma k is the vertex of the parabola. That's why this is called vertex form. So this is really helpful and super easy to find the vertex. If I'm looking at this function, I know the vertex is going to be positive 4, comma, positive 5. Since it's in the form x minus 4, and remember the equation is x minus h, I know h is positive 4. So if I fill in a positive 4 there, it would have x minus 4. And then in the equation, it's plus k. So I just keep whatever I see at the end. Since I see plus 5, I keep that as positive 5. So my vertex is 4, comma 5. And I know that my a value is positive. So it's going to be opening up. Therefore, it has a minimum value. The min value is the y value of the vertex. So the minimum value of this function is 5. It cannot go below 5. The minimum value is 5. The domain is still going to be all real numbers. The range has a min value of 5, so it can't go below 5. It can equal 5, but it can't go below 5. It can be anything above 5 all the way up to infinity. So my domain and range I have. Now let's go off to the side and actually graph this function. Alright, I got my coordinate plane set up. I know that my vertex is at 4, 5, so I'm going to go ahead and plot that point, 4, 5. My a value is 3, so with an a value of 3, I know that's the same as 3 over 1. I can go up 3, right 1 to get to the first point. And then I can also reflect that. If you want, you can go ahead and draw your axis of symmetry through your vertex so that you can easily see where it reflects to. The point is going to be 3, 8. And there's what my parabola will look like. It's really important for you to notice that the k value in vertex form is not the same as the y-intercept. The k value is the y value of the vertex, not the y value of the y-intercept. If you wanted to find the y-intercept, you have a couple options. You can plug in 0 for x, or you can change this to standard form. But keep in mind, the 5 is not the y-intercept. The 5 is the y value of the vertex when you're in vertex form. I want you guys to try the extra practice problem here. It's the same question, so graph it, find the max or min off of this vertex form, and then check if you got the answer right. And finally, we're going to look at graphing from intercept form. So we've already seen standard form, vertex form. Now we're looking at intercept form of a quadratic. So notice in the box here, we have the factored form or the intercept form of a quadratic. It looks like a multiplied by x minus r1 and x minus r2. r1 and r2 stand for root 1 and root 2. You know, hopefully, that the roots are just another word for the x-intercepts. So those factors help you find the x-intercepts, and then you can find the vertex by finding the average of the x-intercepts because of the symmetric property of the parabola. The vertex is going to be halfway in between the two roots. So we can just average them to find where the vertex is going to be. So if we're looking at this example, we see that the first factor is x minus 3. I know that the formula is x minus r1. So I know that my r1 would have to be 3. That should make sense to you because hopefully you remember that when you solve x minus 3 equals 0, you would add 3 on both sides, giving you x equals positive 3, which is why it's not negative 3, it's positive 3. And then looking at the other factor, x minus 4, I know that my second root, r2, is going to be positive 4, similar to the last problem. How I showed you, you would have added 4 on both sides and gotten an x value of positive 4. So I have my x-intercepts are 3 and 4. After that, I can figure out where the vertex is by averaging those two values. So what I can do is I can find the x value of the vertex by averaging. Remember, average means you add the values together and divide by how many values there are. So in this case, there's always going to be 2. There's 2 x-intercepts here. A parabola can't have more than 2 x-intercepts. It can have 0, 1, or 2. This one has 2. So when we add this, we have 7 over 2, or 3.5, or 3.5 is our vertex, our x value. And then to find the y value, I'm going to plug that back in. So I need f of 3.5. So 2 times 3.5 minus 3 times 3.5 minus 4. With these decimals, I think it's going to be more efficient to use my calculator, so I'm going to pause and do that. I got the y value is negative 0.5 or negative 1/2. So putting that together, my vertex point is 3.5 comma negative 0.5. Looking at my a value, I see that a is greater than 0 or it's positive. And that tells me that my parabola opens up. Therefore, it has a minimum. And the minimum value is the y value of the vertex. So min value of negative 0.5 for this function. Just like all the other quadratics, it has a domain of all real numbers. And the range, since this opens upward, is going to be starting at the minimum value, negative 0.5. It can't go below that. It can be anything above that up to infinity. Now let's look at this on a graph. All right, so you'll notice that I went ahead and made a coordinate plane here. I did the scale on this as 1/2 for both the x-axis and the y-axis. Your scale for x and y don't have to match, but you do need to label it if you're not doing a scale of 1, just so that everyone who views your graph can see what you're counting by. And you can pick whatever you want as long as you just label it on your graph. So I know I had an x-intercept of 3, an x-intercept of 4, and then I found out that halfway in between those x-intercepts was 3.5, so that's where my axis of symmetry was. My vertex is somewhere with an x value of 3.5, and when I plugged in 3.5, I got negative 0.5, so that was my y value of my vertex. And notice that makes my parabola open upward. And again, if you wanted to find the y-intercept on this, you could always just plug in 0 for the x values and simplify it to see what you got. But it didn't say anything about making a certain number of points. We just needed a graph, so the vertex and 2 more points is plenty. you can see where the parabola is and fill in that graph. All right, there's one more practice problem for you to do. It's the last one for you to try today. And then hopefully you have a pretty good understanding of graphing quadratics, or problems that have x squared in them that make a parabola on a graph. With those graphs, they do always make a parabola, and you should be able to graph them from standard form, from vertex form, and from quadratic form. Here's that last practice problem so you can try it on your own and then check and see if you got it right. Here are the answers for the questions, and then here is that graph. All right, so there's that graph, and that wraps up the lesson for graphing quadratics. Bye, guys.